Hey guys, welcome back to Algos Made Simple. Today we got a little bit of a tougher one, but we're going to make it as simple as possible like always. This is Leetcode238, product of array except self. And the title of this one kind of gives away what we're doing. We're getting the product of an array, an entire array, except for the number that we're at. And it states, given an integer array nums, return an array answer such that answer at index I is equal to the product of all the elements of nums except nums at index I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time without using the division operation. So I would let the interviewer know, okay, I understand I'm getting an array of numbers, and I want to return an array as well that at that index that I'm at is the product of the entire array except for the number that I'm currently at the index of in nums. So I understand conceptually what we're doing here, and that would just lead me to go to the example here. We've got input nums equals 1, 2, 3, 4, and an output of 24, 12, 8, and 6. And as you can see why they want to allow you to use the division operation, well, if you just multiplied all these numbers together and then divided it by the number, 24 divided by 1, 24, 24 divided by 2, 12, 24 divided by 3, 8, 24 divided by 4, 6, it's just too easy. And we can't do it in worse than O of n time. That would allow us to do the double nested for loops and again have a very easy solution here. So if it doesn't pop out to you immediately what's going on here, you know just by the description that you want all these numbers to be in this index on the array, on the answer array that you're returning. So what you need to do, and this is where examples come in, you go through here, you've got 1, you know it's everything to the right. Okay, got it. 2 is everything to the right and everything to the left. 3 is everything to the left and everything to the right. 4 is everything to the left of it. So we know it's going to be kind of a unified code. When we make this code, it's got to work for every single number. So you don't want to have something where it's like trying to find if it's the beginning number and then it only does the numbers to the right of it. And then if it's the ending number, it only does the numbers to the left of it. Just a lot of complicated stuff to do there, and it'd be hard to keep track of in your for loop. So what you want to do and get to thinking about, even if you're stuck here, it's always good to go ahead and start writing a game plan. This keeps you writing, keeps you talking, keeps you going. So we know we want to return an answer array. So we got that on our checklist. Boom, easy. We got something going here. And we know that we want to get the product of these numbers. Just if you're picking any kind of random number in the middle, you want it to be the all left numbers times all right nums. That would give you that index. So we're clear on that. So what are we going to do to make it kind of uniformed for this number 1 and this number 4, or whatever our numbers end up being there on the start and the finish of the array? Well, there's nothing to the left or to the right, and it's multiplication. So if we had them set equal to 1 initially, that's not going to hurt us or change anything. So then you can get all the numbers to the right of this 1, times it by the left 1, boom, nothing's changed. It's all the numbers to the right. And same thing goes for this 4. You have all the numbers to the left of it times its right 1. It's going to be the exact same thing we want. So we've got a game plan together. We've kind of figured it out conceptually on this one that it's just, hey, we need the product of all the things to the left and all the things to the right. So how would we attack the code on it? Let's get rolling on it here. Product of array except self, and we're taking the parameter nums, pass through it. So what we want to do, stick to your checklist here. We know we need an answer array, and we know that we're not going to be going through any kind of nested for loops. If we have multiple loops, they're going to be on the same indentation, so it'll be running O of n. So we know we need an answers array. So let's go ahead with it being multiplication and set it up as an array full of 1s that is going to be the exact same length, because we know we're returning the exact same length. There's one thing we know for a fact, is that our nums array and our answers array are going to be the same size. So we want this answer to equal be an array of 1s that is equal to the size of length and num. So at this point, all we've done is just have an answer array, however many numbers are in it, but let's assume it's like the example here. We just have an answer array of ones. Okay? So the next thing we have on our game plan here is we have our left equal to 1 and our right equal to 1 to take care of these extreme, base cases right here where you have to start or you have to finish. So now we've done everything in our game plan. What's next? As we said a million times on this channel, if you haven't utilized a for loop yet in your solution, it's probably time to utilize some sort of loop, probably a for loop in your solution. So we know the next thing we can do, because we run out of runway in our game plan, is to utilize a for loop. And we know we want this for loop to be able to fill in an answer while it's taking a number from nums or whatever. So we can't just say for num and nums, because then we have to fill it in the right index kind of thing. So let's do for I in range length of nums. That'll allow us to pull the index and have it work for the answer and work for the nums to be able to pull the number. So everybody's tracking there. We know that we're going to update this answer at that index. So we got that on there. So what would it be equal to? Well, whatever is already in that index, especially once we're starting to do the right part, we want to have the answers from the left. And then we're just going to multiply it by our left variable. Okay, so that works great for, index 0 here. We have 1, and it's just going to be the answer is what's at index 1. Index 0 is a 1, and it's going to be times by the left 1, so we're going to get a 1 kind of like we anticipated here. Everything to the left of it is 1. So again, this is how we're getting everything to the left. So then we come here, our left has to be updated, because once we get this 2, it's not going to be just what's at answer index I. We want to have everything that's been to the left of it too, so we want to have this 1 as well. So what we'll do is left equals left, what we've had so far, times the number that's at that index. And what that'll allow is once we get to this 3 here, we'll have 2. Once we get to this 4, we'll have the 6. So that'll give us our lefts. So we're done calculating the left side at that point. That's gonna return us an answer array that's gonna look like this right here. We'll have 1 in that spot. We'll have for 2, everything to the left of it, it's gonna be 1. For the 3, everything left of it will be 2, and for the 4, it'll have 6. So at that point, we've got an answer array of 1, 1, 2, and 6. So we have all the things that have happened to the left of it. So of course, that's not where we want to be. We want to be this 24, 12, 8, and 6. And we're going to get there by doing the right. Well, to do the right, with that right starting off at 1, we know we want that right to be at 1 when we're dealing with the last element. So we're going to have to do this in reverse. So you want to set up I for your index to be equal to the length of nums minus 1, because we're doing indexes, so we're going to start off at 0, or not start off at 0, but we're going to include 0. And then we'll say, while I is greater than or equal to 0, because again we want to include that 0, and then it's just time to get this right side multiplied in. So we'll start with our answer at index I, which again here would be the far right, and we're going to say that our answer at index I is equal to the answer that's already there, so all of our left elements, times the right, which in this case is 1. So what'll happen there, we're dealing with this 6, it'll have 6 times 1, and it'll be 6, which matches up with our output up here. So that's great, we're on our way here. So just like we did with the left, we have to say right equals what we've had on the right side so far, times the number at that index. So again, the number on that last one. So that would be 4 in this case. So now our right is 4. And the only other thing you got to do, because we're in this while loop and we want to exit it one day, we don't want to get stuck here, is do this I minus equals 1. And that's just going to bring the I down by 1 and get us to our next answer key here. So our next answer will be working with this 2. We said the right is equal to 4 now, it's going to produce an 8. So we got 6 and 8 just like we're supposed to. It'll come down here, have the right so far, which was 4, times the number at index I, which is this 3, 12. So our right's now 12. We'll come up here, the I is down another one. We're working with this 1. 1 times 12, 12. It'll take 12, the number at that index, which was 1. Or I'm sorry, that was at that index, which is this 2. So I have 12 times 2, 24 is our new right. Answer at index I is the 1. 1 times the right is 24. We'll have our 24, 12, 8, and 6 just like we wanted to. So all that's left to do after that is you're just going to return your answer array. So hopefully that makes a lot of sense there and kind of simplifies it. You just want everything to the left and everything to the right. And of course, to do the right, you have to do the opposite way you did the left. So you got to get at this opposite index. And we kind of already went through and did the test while we were talking about it. And you see your answers after we go to the left, we had a 1, 1, 2, and 6. And then it's going to be multiplied by everything on the right. So again, you have the 1 and you get your 6. You have the 2. So you're at 2 there, and you're kind of so on and so forth. So with that being said, this runs in just as requested, O of n time. So there's your solution for that one, guys. Thanks for hanging out. We're going to keep tackling problems. They're going to vary in difficulty, but we're going to try to do some stuff that we, will prepare us for our interview and stuff we think we'll run into in the future. So again, thanks, guys. Please like and subscribe if you found anything helpful, and we'll move on to the next one.